For our next video, we're going to look at systems of equations. So a system is when you have more than one equation put together, and we're going to be looking at linear systems. So we have our different linear equations that we're putting together, and we're looking for the x and y that's the same in both equations. So keep that in mind. The answer to our systems of equations, well, there's going to be a couple options, but we're looking for a point. We're looking for an x and a y that make it to where these are the same, and we'll kind of get into that. We have three ways of solving systems of equations. The first option is by graphing. So again, I'm looking to see where these two equations are the same. So I'm looking for the x and the y where they're the same or where they meet. Okay, so if I'm graphing, I'm looking for the intersection of those two lines. Right, so I'm going to start just by graphing. All these ones are in slope-intercept form. If they're not, you can quickly put them in slope-intercept form by getting y by itself. And then we'll graph using our y-intercept and our slope. So for the first equation here, I'm going to start at positive 3, which is up here. And then my slope is 4. So that means I can go up 4 over 1 or down 4 left 1. It's the same thing, right? I'm going to get a couple points. I usually say to fill up your grid, right? Because you want to see exactly where your line goes. You want this to be a little more exact as opposed to a sketch, and you'll see why in a second. Our second line, negative x minus 2, I'm going to start at negative 2. And then my slope is negative 1. So that means I can go down 1, right 1, right? Or I can go up 1, left 1. Okay, and I'm filling in a few more than we need. And the solution to my system is where they intersect. So my intersection is right here, and that coordinate point is negative 1, negative 1. So that's the solution to this system. So by graphing, you graph both of your lines, or any shape you have if we're not doing linear, and then you find where they intersect. All right, for the second one, I'm going to do the same thing. So my first equation, I'm going to start at positive 3. Then I have a slope of negative 2, so that means I'm going to go down 2, right 1. All right, and when I do these, I'm going to take my first line and go several points in both directions, just so that I can easily see where it crosses. Like here, I can see where my points were even though my line wasn't perfectly straight. Okay, and then for the second one, I'm going to start at positive 4 and a negative 5/2. That means I'm going to go down 5 and then over 2. Now, I see that I already intersect, so I'm going to stop. I don't have to keep counting and putting more points. I just need to figure out where they intersect, all right? And that point here is at 2, negative 1. So that's the solution to that system. Okay, and then for the third one, all right, the first one is negative 2x plus 2. So then I'm going to go down 2, right 1, down 2, right 1. Okay, fill up. Draw my line. And then for the second one, I start at negative 2, and I have a negative 2 slope again. So I'm going to go down and then up, and if you notice, it never crosses. Okay, so that means that these lines are parallel, right? And parallel lines never touch, so that means that my answer to this system is no solution. They never have a point in common, right? So you can graph these, or we talked about parallel and perpendicular lines. If you can recognize it before you even graph, and you can see that they have the same slope, you don't even have to graph it. As soon as you see they have the same slope, you know that those are going to be parallel lines, and you can go straight to your no solution because parallel lines never touch. Right? So the first option we have is graphing. The second option is substitution. Right? Now, substitution will work every single time, and so will graphing. Okay, but substitution is an algebraic way that works every single time, and the second one we'll look at, or a third option in a second, doesn't always work, right? But for substitution, no matter if you have linear, quadratic, any type of equation you ever work with, you can always solve it by substitution. All right, so substitution, just like, you have the word substitution, like if I'm not at school teaching one day, you have a substitute teacher, somebody that takes my place. So what we do with substitution is we're going to end up substituting one of the variables. Like right now, I can't solve for x or y to get down to a number. I can't figure out what x and y equal because there's two variables in there. So what we do is we pick one variable to isolate, to get it by itself, and then I'm going to plug into the other equation. That sounds crazy. Whenever you pick your variable, pick one that is either already by itself, like for example number 2. I would go to get y here by itself because I don't have to do anything except move the x over. Less work on my part. You can pick any variable you want to, but try to pick one that's going to be less work for you. So I'm going to go with get the y by itself here. I'm going to get the x by itself here because if I start to get the x by itself, eventually I'm going to have to divide by this -2. Well, 6 and 6 are both divisible by 2, so I'm not going to have any fractions in there if I get this x by itself. Again, you could pick any variable. So this is my goal. I'm going to get this -2x by itself and then get the x by itself. So I'm going to rewrite it down here. All right, I'm going to start by subtracting the 6y from both sides. Okay, so I get -2x equals 6 minus 6y. And then I'm going to divide everything by -2 to get the x by itself. So we get x equals -3 plus 3y. All right, once you get one variable by itself, I'm going to take what I know x equals, right, this -3 plus 3y, and I'm going to plug it in to the x of the next equation. Okay, because remember, if my solution, x equals, is going to be the same in both equations, because that's what I'm looking for. I'm looking for what makes x the same in both equations. All right, so for this one, I'm going to say -7, all right, times, and instead of x, I'm going to plug in -3 plus 3y. And then I got plus 8y equals -5. And again, we can do this because x has to be the same in both equations, and so does y. But now I have an equation that only has a y in it, which means that I can solve for y and get down to y equals a number. All right, so I'm going to start with distributing. Oops. So I have a positive 21 minus 21y plus 8y equals -5. Okay, and then I've got common or like terms in there. So we can say, oops, my paper don't want to stay still. -21y plus 8y. So we have 21 minus 13y equals -5. All right, I'm going to subtract the 21 over. All right, so I get -13y equals -26. Divide by -13. And we get y equals a +2. All right, that's half of my answer. All right, so I'm going to come back up. I know what y is, so my answer is going to be something, 2, but I got to figure out what x is. Well, lucky for us, I have an equation for what x equals. I know that x equals -3 plus 3y. So that means x equals -3 plus 3 times 2, which is -3 plus 6. So then I get x equals +3. So my answer is 3, 2. All right, now those take a little bit longer. Okay, so I only have one more for us to go through. All right, and then for this one, like I said before, I already have y. That's kind of pretty much by itself here. All I have to do is get rid of that x. So I'm going to get the y by itself just to make my life easier. So I'm going to add x to both sides. So I get y equals 3 plus x. So I'm going to take what I know y equals from the second equation and plug it into the y of the first equation. So we have -3x plus 3, and then instead of times y, we're going to say times 3 plus x. And that's got to equal 4. So I'm going to distribute. So we say -3x plus 9 plus 3x equals 4. I got my like terms. Right, -3 plus 3 is 0, right? So these are actually going to go away. And I'm left with 9 equals 4. Okay, now I have no x's left. I have nothing to solve for. And I get down to this statement. Well, this is a false statement because 9 does not equal 4. So that means I can put a little slash there. 9 does not equal 4, which means that this one is a no solution. Okay, so whenever you're solving, you're either going to get down to numbers and you can figure out your x and your y, or you're going to get down to a statement. And if it's a false statement, it's no solution. That means that these lines are parallel, and had we graphed them, they would never touch. Okay, now our third option, well, if I can find my paper. Our third option is elimination, and this one's a little bit easier, but it only works when you're working with linear equations, right? Or at least it's easiest when you're working with linear equations, right? So I've got 4x plus 8y equals 20, and then a 2y equals 4x minus 30. Before we can start the elimination process, right, I need to get x and y on the same side, and specifically I need to have the x first, then the y equals a constant. So what we're going to do is take this equation, let me change colors here, and I'm going to subtract 4x from both sides. All right, and then I'm going to bring everything down. So I'm going to bring down my first equation here, just like it's written. And then I'm going to write my second equation with my x and y on the same side. So the x comes first, so that's a negative 4x, and then I have plus 2y equals a negative 30. All right, so you have to get it set up this way where x and y are on the same side. X comes first. And then we're going to do our elimination process. So the whole point of elimination is to eliminate, right? I want to eliminate a variable because as long as I get rid of one variable, I can solve and get down to a letter equals a number. That's my goal. All right, so the way that you do this is you look for one of your variables to cancel when you add. So here I have a positive 4x and a negative 4x. Those cancel each other out, so I'm good to go. I can go ahead and do our elimination. So we're going to add our equations together. Well, 4x and negative 4x cancel. All right, that becomes 0. Then 8y plus 2y gives me 10y, and then 20 plus negative 30 gives me a negative 10. All right, then I just solve for y. So I can divide by 10, so y equals negative 1. All right, well, there's my y value. So now to get my answer, we plug it back in. So that means I'm going to take my y and plug it into either one of the equations. Does not matter which one. I'm just going to pick the top one because I usually pick the top one. So we're going to say 4x plus 8 times 1 equals 20. So that's 4x plus 8 equals 20. Subtract the 8. So we get 4x equals 12. Divide by 4. And we get x equals 3. And then you write your ordered pair. So my answer for this system would be 3, negative 1. Okay. So when you solve by elimination, you have to get x and y on the same side and then look for something to cancel. Right now, for the next one, I have x on y. I have x and y on the same side for both top and bottom. Okay, so I don't have to move anything. So now I'm looking for something to cancel. Right over here, the 4 is canceled right off the bat, so I could go straight into elimination. But here, nothing cancels. Right? I don't have any opposites on here. So that means I have to manipulate my equations. I can multiply my equations by anything as long as I multiply everything by that number. And that doesn't change my equation, it manipulates it. So for example, I know that I could easily change my equations and get my x's to cancel, right? And I can do that if I make this top x a 4x, because 4x will cancel a negative 4x just like we did over here. But in order to make this x become a positive 4x, I have to get rid of the negative and go from 1 to 4. And I can do that all in one step by multiplying by a negative 4, because negative 1 times negative 4 is positive 4. So then when I do that, I end up with a positive 4x, right? And then negative 4 times negative 7 is a positive 28y. And then 14 times negative 4, I'm going to do this one in my head, get 40, 56. So we get a negative 56. Then I can bring down the next equation. I don't have to change it, so we're going to leave it just like it is. And that equals 28. Now I have something that cancels, so I can add. X's is what cancels. That's what we did this for. right? And then I have 28y plus a negative 14y, or 28 minus 14, so that's a 14y. And then I have negative 56 plus 28, and that's going to give me a negative 28. Now I can solve for y by dividing by 14. So y equals negative 2. But I'm not done yet. We got to plug it back in. So I'm just going to pick the first one again. So I'm going to say negative x minus 7 times negative 2 has to equal 14. So negative x plus 14 equals 14. Subtract 14, so we get negative x equals 0. And I have to get rid of that negative. That's a negative 1. So I'm going to divide both sides by negative 1. But 0 divided by anything is 0. So my ordered pair is 0, negative 2. All right, you got to get one of your variables to cancel. It doesn't matter which one you get to cancel. Okay, for the second one, or the third one, right, I have my x's and y's on the same side, so we're good there. But none of my variables cancel again. All right, so for this one, it's a little different. Now again, you could pick cancel the y's or the x's. That part doesn't matter. In this case, I'm going to pick the x's again. And 2 and 5, like there's nothing I can do to 2 to make it be a 5. And there's nothing I can do to 5 to make it be a 2, right? Or nothing easy that I can do. So I'm going to have to change both of these so that they get to something that cancels. Well, 2 and 5 both go into 10. So that means I can multiply the top equation by 5, and that's going to get me to a 10. And then I can multiply the bottom equation by 2, and then that'll take my 5 and get it to 10. And I already have one positive and one negative, so I don't have to worry about changing signs. All right, so I'm going to take the top equation and multiply it by 5. So we have 10x plus 40y equals 30. All right, so there's my top equation. Then I'm going to take the bottom equation and multiply it by 2. So I have a negative 10x and then plus, minus 40y equals a negative 30. And now we can add top and bottom. So the x's go away, right? That's the one that I wanted to cancel, okay? Then I have 40 plus negative 40, which ends up being 0, right? They cancel too. And then I have 30 plus negative 30, right? And that's going to end up being, a 0. So then I have 0 equals 0. So this time my variables went away again, right? I had x's and y's, and I got down to where I don't have any x's and y's left, so I'm down to a statement. Remember, if it's a false statement, that means that it's no solution. But in this case, 0 does equal 0, right? That's a true statement. So if it's a false statement, it's no solution. If it's a true statement, we have a couple different things you can say. We can say we have infinitely many solutions, or we can say that we have, or we can say that our equations are the same line. Okay, and what that means is that when I were to graph these, they would be like the first one I would graph, and then the second one would technically graph right on top because they're the same line. So they're always touching, they're always intersecting, so that means that all of your answers work, all real numbers. All right, so you're going to get down to an x and a y, or you're going to get down to a false statement and it's no solution, or you'll get down to a true statement, and that means that they're the same line, so it's infinitely many solutions.